In 2012, a computer learned to see, and nobody noticed. For most of the 2000s, artificial intelligence was a punchline. Self-driving cars kept crashing. Voice assistants misheard everything. Experts argued AI was 50 years away. The public had basically given up. The core problem was image recognition, teaching a machine to look at a photo and correctly name what's in it. By 2011, the best AI systems were still getting it wrong more than 26% of the time. That sounds small, but for a computer trying to reliably identify a dog from a cat, it was a disaster. The three ingredients that had been missing finally came together at once: massive labeled datasets, cheap, powerful graphics processors repurposed for math, and a decades-old idea called the neural network, finally given room to breathe. These three forces collided in September 2012, and everything changed. AlexNet was built by three researchers at the University of Toronto: Geoffrey Hinton, Alex Krizhevsky, and Ilya Sutskever. Their network had 8 layers, 60 million parameters, and trained on 2 NVIDIA GPUs. It cut the error rate almost in half, from 26% down to 16%. The margin of victory was so large that judges thought there had been a mistake. The ripple effects were immediate. Within months, Google bought Hinton's startup for $44 million. Within a year, every major tech company quietly hired a deep learning team. The ImageNet leaderboard became a battlefield. The error rate kept falling, past human level by 2015. If AlexNet was the spark, AlphaGo was the explosion. Go is an ancient board game with more possible positions than atoms in the observable universe. Experts said mastering it was 100 years away. In March 2016, DeepMind's AlphaGo defeated 18-time world champion Lee Sedol 4 games to 1. Millions watched live. Grandmasters called it moves they had never imagined. What made AlphaGo special wasn't brute force. Earlier chess computers like Deep Blue memorized millions of positions. AlphaGo learnt by playing millions of games against itself. It invented strategies no human had ever tried. This was the first time an AI didn't just compute, it created. The word creativity suddenly appeared in research papers. 2017 brought a quieter but equally important breakthrough: the transformer. Researchers at Google published a paper titled "Attention is All You Need." It introduced a new way for neural networks to process language, not word by word, but all at once, weighing the relationship between every word and every other word simultaneously. The Transformer paper unlocked a simple but profound idea: scale. If you made the network bigger, fed it more text, and threw more compute at it, it just kept getting smarter. OpenAI ran the experiment. In 2018, they released GPT-1. Decent, but not impressive. GPT-2 followed in 2019. It was so good, they briefly refused to publish it, fearing misuse. GPT-3 arrived in June 2020 and stunned the developer community. Without any specific training, it could write poetry, debug code, translate languages, answer medical questions, and pass parts of the bar exam. Nobody designed those abilities, they just emerged from scale. Researchers started using the word emergent to describe capabilities the creators hadn't anticipated. To understand why GPT-3 felt so different, you need to understand the timeline of compute. From 2012 to 2020, the amount of compute used to train frontier AI models doubled roughly every 3.4 months. That's faster than Moore's law. By GPT-3, OpenAI was using 3,600 petaflop days of compute, about 300 times more than AlexNet needed. While language models were scaling up, A parallel revolution was happening in AI safety and alignment. OpenAI developed a technique called reinforcement learning from human feedback, or RLHF. Instead of just predicting text, the model was rewarded for giving answers that humans rated as helpful, harmless, and honest. This was the missing ingredient between a raw language model and a practical assistant. On November 30th, 2022, OpenAI launched ChatGPT. It was described internally as a low-key research preview. No one expected what happened next. In 5 days, it reached 1 million users. In 2 months, 100 million. It became the fastest-growing consumer application in history, beating TikTok, Instagram, and every app that came before it. ChatGPT did something no AI had done before. It put a general-purpose intelligence in everyone's browser. Not a toy, not a demo. Something that helped people write emails, debug code, plan meals, study for exams, and process grief. For the first time, ordinary people weren't just reading about AI, they were using it, every day, for real things. The shock of ChatGPT forced every major tech company into emergency mode. Google, which had actually invented the Transformer, had held back its own chatbot, worried about reputational risk. Now it fast-tracked Bard. Microsoft invested $10 billion into OpenAI and rushed AI into every product. The race was no longer academic, it was existential. Then in March 2023, GPT-4 arrived. The leap was extraordinary. It passed the bar exam in the 93rd percentile. It scored in the top 10% on the SAT. It solved graduate-level problems in chemistry, biology, and law. Not by looking them up, by reasoning. Researchers began using a new phrase: artificial general reasoning. Here's the full arc. 12 years collapsed into one view. From AlexNet cutting image errors in half in 2012, to AlphaGo in 2016, to the Transformer in 2017, to GPT-3 in 2020, to ChatGPT exploding in late 2022, to GPT-4 clearing human-level benchmarks in 2023. Each milestone wasn't just a step, it enabled the next one. So why didn't anyone see this coming? The honest answer? A few people did. Geoffrey Hinton warned for decades. Ilya Sutskever wrote papers predicting emergent scale. But the dominant narrative, built on decades of broken AI promises, drowned them out. The gap between what researchers knew and what the public believed was enormous. And then suddenly, the gap closed overnight. By 2024, the numbers are staggering. Global AI investment surpassed $300 billion annually. Over 50 countries launched national AI strategies. The GPU, once a gaming chip, became the most strategically important piece of hardware on Earth. NVIDIA's market cap crossed $2 trillion, making it briefly the most valuable company in the world. Here is what the whole story really tells us. Every single breakthrough on this timeline was built on the one before it. AlexNet proved deep learning worked. AlphaGo proved it could reason. The Transformer proved it could scale. GPT-3 proved scale produced emergence. RLHF proved it could be tamed. ChatGPT proved the public was ready. None of it was random. It was a chain reaction, ignited in 2012 by 3 researchers and 2 GPUs. The exact moment AI stopped being a joke was not when ChatGPT launched. It was not when AlphaGo won. It was a cold September morning in 2012 when a graduate student uploaded a set of results to a competition leaderboard, and the number next to his team's name was so low the judges reloaded the page. That was the moment. Most of the world just didn't notice for another 10 years. What comes next is genuinely unknown, but the pattern is clear. Every time researchers said a ceiling had been reached, the next model broke through it. Every time the public said AI couldn't do something, write, reason, create, it quietly learned. The lesson of the last 12 years isn't that AI is magic. It's that we are systematically, reliably bad at seeing how fast a chain reaction moves once it starts.